Hello, and thank you for studying CCNA with Vambar. Today we'll discuss a routing protocol called OSPF, or Open Shortest Path First Protocol. Just like RIP, which is another routing protocol that we studied in ICND 1, the main function of OSPF is to provide a way of communication between routers so they can be able to exchange information of how to find the best path to a given network or a given destination. However, there's a lot more to OSPF than just this. That is why the first thing we'll do is to familiarize ourselves with some of the features that OSPF possesses. And then we'll see how OSPF constructs a topology, a hierarchical topology. And only after that, we will talk about how to configure, verify, and troubleshoot OSPF. First of all, OSPF is said to be a link state protocol. Link state protocols are a newer generation of protocols that provide much more flexibility and stability than all the networks, or than all the protocols, but require more processing power. If you have trouble remembering more about the link state protocols, I suggest you go back and overview the video regarding distance vector and link state protocols that it is in the ICND 2 part of the course. As a link state protocol, OSPF has a full scope of the topology. That means you can see everybody within the topology. And because of that, OSPF is able to detect loops, and because of that, OSPF can provide us with 100% loop-free topology. That means that there is no chance within OSPF a packet to go to the same place where it was originally sent. Because OSPF can see the entire topology, it can communicate directly with every router within that topology and not only with directly connected routers. This allows OSPF to provide you with a fast convergence in case of a topology change. As a typical link state protocol, OSPF performs classless routing. This means OSPF understands VLSM, or variable length subnet mask, and is able to perform CIDR, or what we know as classless into-domain routing. This means that OSPF now can route packets with IP addresses 10.10.10.10 and a subnet mask of /24 or /27, which is not the default subnet mask for class A, which 10.10.10.10 is a class A IP address. OSPF uses what we know as cost as a metric to find the best path to a given destination. The cost is based on the bandwidth of the interface, and thus the router will prefer to send the traffic over a gigabit interfaces rather than fast Ethernet interfaces, because a gigabit interface has more bandwidth than the fast Ethernet interfaces. Because OSPF requires a lot of processing power to communicate with everybody within the topology, OSPF does not send the entire routing table with the routing updates like RIP. It sends only what we know as partial triggered updates. In other words, OSPF sends routing updates only when there is a network change, and in those updates it includes information regarding the network update or the network that got changed only, which is basically a typical link state protocol feature, and it is possessed by all link state protocols. These updates are called link state advertisements, or just LSAs. And last but not least, the administrative distance of OSPF is said to be 110. And just for a reminder, the administrative distance is a unique number associated with every routing protocol, so that the router, based on this administrative distance, can choose which routing protocol to trust to provide him with the best path to a given destination, in case there is more than one routing protocol installed or running on the router. So let's see how we can configure basic OSPF. Well, the first thing that you would have to do, or you have to type, is in global configuration mode you would have to type the command router OSPF and then some number. This number is called a process ID and is said to be locally significant. This means that the number doesn't have to match between two routers in order for them to communicate properly, and it is only an internal number used by the router to differentiate between different OSPF implementations running on the same route. As I said, the command is done in global configuration mode, and what it does is just enables OSPF as a process, but it doesn't do much else. The command to get OSPF communicating with the remote devices is the network command, then some network, and a wildcard mask, and then in what area do you want this network to be. But let's just take a minute to see in details, or to discuss in details, how exactly this command works. When you first type this command, there are three things happening on the router. First, the router will enable all the interfaces that have IP addresses belonging to that network that we had just typed with the network command, and it will place those interfaces within the area that we just also provided with the network command. The second thing the router will do is that it will start sending hello packets throughout those enabled interfaces, or those OSPF enabled interfaces only. And after the router becomes enabled with some other router, it will send him an update, or LSA like we know it already. And inside of this update, it will contain a list of all the networks of all the OSPF enabled interfaces, and a list of all other networks that the router has learned from some other neighbors. And that's it. Those are the only two commands that you would need to configure a basic OSPF, and you'll be able to run OSPF on your routers. But now let's see some examples of how to configure OSPF on a router. Imagine this is our topology, and we would want to configure OSPF on all the routers, but we'll just start with router A. And router A has two interfaces connected to router B and router C. Those are the interfaces 000, 001, and then it has a local area network which is connected to interface FA0/1, or fast Ethernet 0/1. And we would want to make this router belonging into area 0. So let's see how we can do this. Well, the first thing is, in global configuration mode, we would have to type the command router OSPF and a process ID. Reminding you again, the process ID is just an internal number, so it can be any number. Right now, I'm just going to use 5 for router A. This command will take me into what we know as config-router mode, or which is the router's sub mode, or the configure routing protocol's sub mode. And in this mode is the place where we type the network command. So the first network that we want to advertise to the other world, and we potentially want to enable it, is the network that is connected to our FA00, or the local area network. Well, based on the IP address and the subnet mask here, I know that the network is 192.168.1.0, and that is why I'm typing the command network 192.168.1.0 and a wildcard mask 0.0.0.255, and I will want to put this network to be in area 0. That is why I'm typing area 0 in the end. If you have troubles figuring out how I got to that network, or how I choose this wildcard mask specifically, please refer to the subnetting videos that are in the ICND1 part of the course. Second, we would want to enable OSPF on the interface 00/0, and then based on the IP address of that interface, I would have to type the command network 12.12.12.0, some wildcard mask 0.0.0.255, and then the area 0. And the last interface I want to enable OSPF on is the 00/0/1, and based on its IP address, I would have to type the command network.13.13.13.0, 0.0.0.255, and then area 0. Just a quick reminder, what happened here when we type those commands is that when we type, for example, the network 12.12.12.0, 0.0.0.255, area 0, the router A enabled OSPF on interface that has an IP address that belongs to this network. Well, your only interface that has an IP address that belongs to the network 12.12.12.0 is 0001. Then it will start exchanging hello packets throughout that interface, and when it forms neighbor relationship, in our case with router B, it will send him an LSA with a list of all the networks that have enabled with the network command, which is in our case 192.168.1.0 and 12.12.12.0 networks, plus all other networks that this router might have learned from somebody else, but in this case, or at least in our topology, you haven't learned anything else. So with all those commands, we basically configured the OSPF on router A, and we made a router A, or all the interfaces of router A, to belong to area 0.